Hi, I'm Alex Weiner. My talk is Hobbyist APLing in the 21st century. I'm from New Jersey in the United States of America. That would be right over there. And if that makes no sense, just pretend I'm from New York. And if you're from America, don't tell them any different. Who am I? I went to school for electrical and computer engineering, and that pretty much runs the gamut from physics of electricity up to implementing the hardware that lets developers have opcodes in assembly and some assembly programming. I'm also an APLer. Yeah. Why APL? Well, lots of things can be modeled as a matrix, and I think electrical engineers' favorite trick is, let's make this thing a matrix and then just solve it and be done with it. Circuits, a whole host of other things, pretty much everything. Images can be modeled as a matrix, differential equations, so that pretty much means almost anything can be modeled as a matrix. Also, computer architecture, which is one of my favorite topics. And if that's a puzzler, then you've obviously never heard of this book, which goes and talks about the implementation of a computer architecture. I'm not sure which computer, though. And so what does hobbyist APLing even mean? So I guess I'm defining this. So if you're doing something for a hobby, it should be fun, right? They call work the other stuff. This is the hobby. It should be low cost, or any cost that you can justify to your significant other. You can do something non-practical. You can put a giant Hemi engine in a smart car. It doesn't have to make sense, but it's for fun. You will get frustrated doing it, but overall it should be non-frustrating. At the end you should say, yes, this was great. And then the last thing, which I think is the most important point, is you should learn something. If you learn nothing, I don't think you've done anything. All right, and then we get to this next one, APLing. So it's two parts. It's programming in any APL dialect, or even talking about it. So we've all been APLing right here without even knowing it. In the 21st century, that pretty much means you should be making a web application. If you're targeting a specific operating system, you're going to have to eventually write a web application. And all that means is, at some point, something will spit out HTML, and hopefully it goes to a browser, or maybe inside a dialog session. All right, so let's get down to application development and APL. And so lots of people have given me excuses when I ask them, oh, you should do APL. And they go, no, it's too hard. I can't type it. All sorts of excuses. I've heard nearly everyone in the book. All right. So the first step in development is you have to pick an operating system. And I think these are the only ones, generally speaking. And if we remember one of my core hobbyist principles, that means we can only pick option 1. But you can emulate option 1 on the other two, so it's all the same. Then you have to pick an APL. So we have these APLs. Dyalog APL, I don't need to go over the benefits of that. I think we all know that. We have GNU APL, which tries to be an open source implementation of APL2, but not quite, and it's very buggy. I think it's version 1.6 as of last month. So you can, if you know any good old dialog bugs, maybe send them that way and watch the interpreter blow up in your face. And then also J falls in the category of APL because I believe Iverson had a hand in that. And then we have other. And that's not a typo. J is over there because it doesn't use the fun squiggles of APL. And these other ones I pulled from Wikipedia. We have Arthur Whitney's influence. We have some Windows only or Linux on Wine, or running it in Wine on Linux. Eli, I believe you need to download an IDE, which I got very frustrated using, so I gave up. There's this funny language called S, and actually R is an implementation of S. We have MATLAB and Mathematica, and then I list Go and C++ here because they both have functions called iota, and they both generate indexes. And in their documentation, a little footnote all the way at the bottom says, "Thank you, APL, you invented this." All right, so we have an operating system, we have an APL, or no, wait, I didn't pick one. So I had Dyalog APL, but I lost it and downloaded GNU APL just to continue powering through. I made sure to write my code very portable so that we can get it into Dyalog eventually. But that's what I chose to use. And if you're learning APL, I do recommend a buggy interpreter, because then it'll make you think, wait, did I do that? Or is that something that should work? Then the next thing you have to do is determine an application. This is probably the hardest problem in computer programming, because this is a soft skill. And not many engineers or computer scientists that I know thrive in that. I wanted to do something cool, or at least I thought it was cool. This is very you know. But the most important thing, and what I really wanted to get out of it, was show my friends that APL is really cool, which turned out to be a lot harder than I thought, because you can't just go, look, the arrow means a sign. Isn't that so intuitive? They go, what are you talking about? And what I've discovered is the only way to convince people that don't do programming that APL is the coolest is you write an application that is really cool and then say yes, and it's all in this thing called APL, and you should learn it, because then you can be cool too. For the record, I got one person to do APL after I finished my project, which is a start. So let's get to my application. I called it Flake. It is an image processing program, I guess. Pretty much what it does is there are 3 inputs. 2 of them are images, and then the third input is a tile size. And essentially, we chop our images into tiles, and then we take the closest matching tile, and we kind of make a mosaic of the second image out of the first. If it doesn't click, don't worry, I have pictures. I called it Flake because tile and square were kind of boring names. And also, I don't know if people know this, Flake is a term for someone who doesn't show up for something. They go, oh yeah, I'll see you there, and then they don't show up. We call that a flake where I'm from. And so when I tell people, yeah, I made a web application, go check it out, it's called Flake. It's kind of like halfway no, they're not going to bother checking it out. All right, so let's get to some examples. So this is a painting, and so my friend put this up on my application, and I didn't bother to look at the second image that they mixed it with, but this was the result. Boop. Ooh, ah. And just to prove that you can vary the tile size, ooh, ah, slightly smaller tiles. Once again, non-practical, but very cool looking. Here we have a picture of some flowers, and then we flaked it with 3 different other images. But you can see it kind of gets the same sort of areas grouped together. We got like the darker areas here. So, you know, it doesn't really matter what your secondary image is. It kind of does the same trick. And then this is the famous American rapper Rick Ross, and this is the famous painter Bob Ross, switched with each other. Okay, and so can anyone guess what this is? This is the second image. All right, is it clearer now? Shout it out when you know it. No one? All right, we're getting there. Anyone? Anyone? Huh? Who said that? I'll get you a drink later. So I stuck this in this morning because someone mentioned yesterday it's not a dialogue presentation if there's not a duck in it. But yeah, you can kind of make that out. That's the duck. We got the leg, the head. It actually took longer to find a picture of like yellow and gray to match this picture. So this is currently online at this URL. And if you don't know how to say it, don't worry. There is no real way to say it. It's actually just this pattern on the keyboard. You just go down, then up, and then back down. It is available, so I got it. Be warned. Be warned, it is only a single core computer, and so I guess if more than 5 of you are on it, you might have all sorts of trouble. Okay, so we have our idea, we have our APL, we have our operating system. Let's start developing. And then, so a lot of people do agile development now, but my engineering background says big design up front. Make all our plans, then implement them. So we need some image code. We need to get our image into and out of APL, which is a done task in Dyalog. I decided to painfully make the design decision to use no libraries. I was going to try and write everything myself, and I did. So I need some web code, which means we have to be able to output HTML, as well as take the contents of a web form and get them over to the server for whatever. And then the code that actually does this chopping and matching. This is a visual. And here's a second visual that I worked very hard on. This is probably harder than developing an APL. So we have image on the server. We have some file I/O code. We have the chopping and matching. We have the browser code, and then we have our end user on the other side and the path all the way back. And the goal was do Flake and APL, but then also everything else that is programmable should be written in APL as well, right? So now we get to version 1, and because for many reasons, I used J, mostly because they had the choppy thing built in already. And they also, very deeply buried on the website, had a bitmap library. And I said, okay, I could make this work. So let's look at the architecture. First, we start with a PHP script, and I have failed. A cursory Google search will tell you that when you ask it, how do you get the form data, almost, I think the first 1,000 results or so will just say, use PHP. No reasoning. There's no reasoning. Just use PHP. Here's a tutorial. Here's the syntax. Get going. And, I was younger then and naive, so I did it. And that PHP script calls a bash script, because remember, I only found a bitmap library, but there are many other file types out there. So this does some processing to convert whatever the user uploads to a bitmap so that I know how to read it, and they don't know any better. And then eventually, we call J. Hooray, we've done it. We've used an APL. Good, we're done. Well, this was completely unsatisfying. And just for timeline's sake, I went from knowing 0J to completing the core algorithm in 3 months. And then I didn't really know too much web development, and I was able to slap it onto the web in about a month. I was working 40 hours a week, and when I got home, I would from 6 to midnight every day, and then weekends were, it depended if there was a party going on or not. So then, this was a total mess. Who wants to maintain 3 languages, 2 of which aren't even close to APL, and 1 of which is PHP? A nightmare. So, architecture version 2. Let's write every part in APL. All right, so let's start developing. Almost. We have to set up the keyboard because we want the silly glyphs. They're amazing, they're fun, and people will look at your computer and then walk away without saying anything. Or they'll say, oh, what's that? And then you got them. So Dyalog has a solution, but once again, I wanted to do self-reliance method because they're busy with things. I didn't really want to bug them too much. Most people think this is an APL-specific problem, but it really isn't. This is an operating system problem. The keyboard literally figuring out where in the table to point. It just so happens that it's experienced by a large number of APLers. Luckily, there's this thing called Unicode, and very briefly, this column is every known writable character that has ever been written all the way back to cuneiform, and then this is a column starting from 0, counting up. So we have a universal mapping. There's lots of asterisks on that. Let's not dive into that. But we're lucky. APL was around before anyone thought of Unicode, and we are in there. Here's a quick way to get the keyboard, and so this is downloading the GNU APL project, and yes, there is a file with my name in it. I was very upset at the default key mapping, which destroyed my alt-tabbing ability, which I love to do. And so I dug into the key mapping file and removed the alt mapping, and so now I have a file with my name in it. I'll pat myself on the back for that one. The good thing about GNU APL is that there's very little documentation, so it's easier to read than an entire manual. And this might give you some insight about keyboard setups in the general sense, in case you want to type cuneiform in your APL code. Who knows? Even hieroglyphics. Okay, so now we can really start developing. We have our keyboard, we have our operating system, we have our APL, we have our application. But we don't have any libraries. So this is the general process for writing any library, but this example will go through bitmap. So step 1, look at the specification. Step 2, look at some C code that does the same thing, or insert your favorite language there, but not APL because then we wouldn't be even bothering with this. And then at some point during these first 2 steps, you have an aha moment, and then it's magically completed. So let's look at the specification. So bitmap is a Windows thing, and I read the Microsoft Windows website, and I still couldn't figure it out. And after searching high and low, the most reliable thing I could find was Wikipedia. And if you doubt Wikipedia is a valid source, this is what I used to implement it, and it worked. So I'll trust at least this one page. And it had this very convenient table in there. So this is the file format, and you can see we almost have our vector of values here. They just wrote it in hexadecimal. And if this is an IFL, we actually only really need these 4 fields. The size of the bitmap file, so that we can read in the whole thing very quickly. The offset to where the red, green, blue pixels are. The height and the width. Now that we know our specification, we look at some C code to do the same thing, and then we break into a panic because we realize that C has types, and they're very big on that. I think it's required. They don't let you get away without it. And you go, well, this is all well and good. I could read this, but I'm not exactly sure how this translates into APL. But then you have the aha moment and realize that 32 bits, which is those things, it's just 4 8-bit bytes. And so if you can partition, then maybe you can do something, because you have it segmented already. You have the groupings. And I don't even know how I got to this point. It was very late at night. I realized that the maximum number in an 8-bit integer is 256. And after smashing about every key on the APL keyboard, this is what we got to. And if this rotate is mysterious, this is flipping the most significant bit, because 256 base value of 46, of 46000 is not 46. It is a large number that I can't remember right now. And I don't think anyone would be expected to remember it. But this works. Now we have our 4 very important values, and we can get going. So how do you represent an image in APL? Everyone brace for a good cringe. A 2D matrix of vectors where each vector is a triple. And now you must be thinking, Alex, you idiot. It's all the same type of data. They're all sub-pixel values. Why are you nesting? It's easy. It was easier to look at while coding. Once again, remember, we're thinking of that person who walks by and says, oh, what are you doing? And you can say, oh, look, it's image processing. Look, I have a square, and there's squares, right? But it's slow. We're nesting so unnecessarily. And so this is the algorithm I used. Pardon the line break, but just note that there's an iota here and a divide here, which if you've ever had to implement a hardware divide, you know how slow that could really, 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 really be. And why are we doing math if we're not changing the underlying values? It's stupid. We're only rearranging it. So after I completed the whole project using this premise, round 2 in APL, we did a 3D matrix. And to be honest, since I was beginning, this was easier to do, or easier to think about and use my tricks from C. It's like, oh, I can count, partition. This is kind of not found in many other languages. But you get faster code with less operations, and it's extensible. So for example, a video, you just add another dimension on. This was the code. You have your content. This would just be RGB, 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 RGB. This is width, height, dimension. And you get that. We don't look at this yet. You look at that and you go, oh, I'm so close. And then I said, I should probably rotate this or transpose this in some way. And I'm so lucky that it didn't have to use a left argument, because then that really would have frightened me. And I wouldn't be able to remember it off the top of my head. So now we get to APL on the web. And so we need to know a few things about the web. There's this thing called a web form. It's written in HTML. And they like to say there are 2 different kinds. There's a get and a post. And probably on the same page it said use PHP. They'll explain the differences between the 2. But what they never say, and what you have to read the very technical documentation on, I'm sorry, this is an example. It says get here, and it says post here. That's about the only difference. But what you learn when you read the deep technical documentation is that you don't have to use PHP. It's amazing. Who knew? Apparently no one. But it is a language agnostic protocol. A get, all it is passed as a string where your variables are separated with an ampersand, and you check this environment variable called query string. Beautiful. Post kind of works the same way, except its separator is carriage return line feed. Luckily, we have Unicode, and we know what those are always. And that's just passed to the standard in of the code you executed when you clicked the form button. And I have to thank a very nice Polish guy who gave this algorithm to me to read in standard in until you hit an end of file, where 0 is the tie number. I honestly didn't understand this for about 2 weeks, but I was using it every day. And then I really looked into the star with the dots, and I got it. I do actually understand this line of APL code. So now I'm going to do a little demo of parsing a get. And I'm pretty sure we've all seen this line of APL somewhere, or variants thereof. But yeah, so that passes if your form had 3 things. Now you're chopped, and the rest is left as an exercise to the audience. You could substitute in an arrow for the equal sign and do a 1 drop each. Maybe an execute, but I hear a lot of people don't like that. And then, as promised in the bullet points of my abstract, there are some other goodies that I discovered while learning APL. Indexing. So in other languages, they love to say, we should index from 1. No, we should index from 0. It matches the hardware better. And yeah, I've seen some people get pretty heated over this. And in other languages, they have very elaborate mechanisms where you could actually learn the entirety of the language, and then you have to learn an entire other thing to figure out how to write index-independent code. like in C++, right? Yeah, they have like iterators or something like that. But I will claim that good algorithms are index origin independent, but I must also say that I don't practice what I preach. But it's actually pretty easy. All I need to do is use quad IO 0 and then just add quad IO. This is honestly astounding and unbelievable, and I wish every other language just threw in quad IO so they could just do this instead of creating crazy abstractions on top of abstractions. And then control structures. I have a good friend who's a C++ programmer, and I told him, yeah, we don't have if, we don't have while, like the keyword. And he was immediately turned off. He goes, I can't use this. This must be a fake language. You're making this up. And I go, no, it's very real. Trust me. It's been paying the bills. But we do have branching and line labels, which makes me think this guy probably never did assembly programming, because assembly programming also has branching and line labels. And if you remember from the beginning, I've done some assembly in my life, and so this is AVR assembly. This will run on an Arduino or what have you. And here on the other side is the exact APL equivalent. What's not obvious here is that compare here is actually setting its result into a register that you would only know if you read the manual, and it says compare, puts it in register, whatever. And then branch not equal cleverly knows to check that same register spot. So essentially over here I simulated that with result. And it's kind of amazing because, look, we're practically doing assembly anyway. We have half the same syntax. So I believe that runs, are there any questions?
Is your next step to read the manual? There is actually control structures in APL, at least in Dyalog.
Oh, definitely in Dyalog, and I have used them. This was more an exercise in, here's really why I did it this way, is so if anyone asked me what I was doing, I didn't have to talk about a non-core APL thing. Like, I didn't want to use a namespace because then I have to go off and explain what a namespace is for 20 minutes, and we haven't even gotten to APL. So this was so I could just say, oh, this specific part is using this specific symbol, and grow out from there. Cool, thank you.